Hello Narjis, how are you? Alright then. So today we are going to do, let's see. Right. Paper 1-3. Okay. Hi Anusha, how are you? Hello Manip, how are you? Manip,
How are you?
Alhamdulillah, how are you?
I'm good. Manip, why did you miss your class yesterday?
So, yesterday was actually was a bit busy. That's why.
Okay. So you've
Yes.
done this paper? Or no?
Yes, sir, I did. Paper
Okay.
1 thing.
Okay, very good. So now going to the first question. It says, what is the average thickness of one sheet of the paper?
Sir, can we record?
It is being recorded. Okay.
Okay.
It's on. It's being recording on YouTube, so you'll get it. All right. So, average thickness of a paper book, right? And it has two sheets, 210 sheets. Okay. Well, this seems like 0.9 and this is 3.6, I believe. So 3.6 times 0.9 basically is 2.7 centimeters. Now they want us to find it in millimeters, so that would be 27 millimeters. And then if that is the total thickness, which means you go divide by 210 to find the thickness of just a sheet. Okay, 27 divided by 210, that would be 0.13. 0.13 is C then. What is the unit of resistance expressed in this? So resistance is voltage over current. Voltage itself is energy over charge. So energy is, you can do it like this, mgh or half mv square, whatever you want to take, kg meters per second square times meters over ampere seconds. So it will be kg meter square ampere minus 1 second minus 3. So that would be kg meter square ampere minus 1 second minus 3 and divided by current as well. So kg meter square ampere minus 2 second minus 3. Or you're so good that you remember everything, so that would be even better. So that should be this answer then. Alright, so going to the next one. Which list contains only scalar quantities? Acceleration is not scalar. Density, energy, frequency, velocity is not scalar. Distance, pressure, temperature, and time, these are all scalars. Alright, now going to question number 4. it says what is the frequency of the signal. So this whole length is 4 centimeters, which means the time period would be equal to time base times the length of the signal. So time base is gonna be 2.00 milliseconds per centimeter multiplied by 4 centimeters. So that's going to be 8 milliseconds. So 8 into 10 raised to minus 3, and frequency will be 1 upon 8 times 10 raised to minus 3, because it is basically 1 upon the time period. So this is going to be 125. Has to be B then. Okay, up till now this is pretty simple. After measuring the width of the shelf to be 305, it says it is found that the graduations okay, hold on. Let me turn it up. Okay, it will be fine now. So then basically this it is found that the graduations on the ruler is 1% further apart from it should be. Which type of measurement error is this, and what is the true width of the shelf? So 1% is a constant error, which means it has to be systematic error, and then 1% of 305 is basically, let's try to find that, 305 times 1 divided by 100, that is 3.05. So when you add, because it says it's basically the actual reading is further apart, right? So it has to be a positive error. So what you do always to find the actual value, you do the reading minus the error. So what you do then, 3.05 minus 3.05. So let's 305 plus 3.05. So it's 308.5. So that has to be D then. Alright, now let's go to the next one. And
Sir?
yep.
It says that it's further apart, so shouldn't it be like less?
So the reading is further apart. So it means the actual should be less than that. Do you understand? So the
actual should be less than that, no?
No, what it means is that when you're taking the graduations, the reading is further apart. It means the
Yes, sir.
reading you're taking is larger than it should be. So error should be subtracted, right?
Okay.
Do you understand?
Alright.
That's the sense of it. If it says it was smaller than it should be, then I would add it. Got it? So it has to be negative error. Now, what
Alright.
must be the shaded area under the graph represent? Right. What must be the shaded area? So there's acceleration time. So acceleration is change in velocity upon time. So if you multiply acceleration time, it should give you change in velocity. So it has to be B. Okay. Now a stone is thrown vertically off a cliff and lands in the sea. Air resistance is negligible. Which statement about the motion is not correct? The final displacement of stone depends on the initial horizontal velocity. Final displacement of the stone depends on initial horizontal velocity. That's not correct, because that's actually not correct in the answer, because it is correct as it will go further apart if it's higher. That's not our answer. Let's take it instead. Okay, the stone travels with constant horizontal component velocity. That is also correct. The stone travels with an increasing vertical component velocity. That is also correct. The time taken for stone to hit the surface depends on initial horizontal velocity. No, that's not correct. because time is independent and it would actually depend on how it would actually drop down. So that's basically how you should think about it. Then water is pumped through a hose pipe at a rate of 90 kg per minute. Water emerges horizontally from the hose pipe. This, okay. So you got mass, you got time, that's 60 seconds, and you got speed, which is 20. So that's final speed initial when the water was starting should be 0. What is the minimum force required? Okay, so force is equal to change in momentum upon time. So mv minus mu over t, that should be 90 times the velocity was 20 minus 0 divided by 60. So 90 times 20 divided by 60, that has to be 30 newtons as the answer. Okay, now a skydiver leaves a stationary balloon and falls vertically through a long distance. Fine. Which graph represents the variation of acceleration of skydiver with the distance s? So skydiver leaves a stationary balloon and falls vertically through a long distance. Fine. So the acceleration should actually come to 0 because it will reach terminal velocity. Only this graph shows that. None of the graphs are correct because they don't show 0 acceleration at the end. Now, so two diagrams approaching 2m, it doesn't really matter which is a elastic collision. So you have to use u1 plus v1 equals to u2 plus v2. That's the equation for relative velocities. And then you also take, let's take this side as positive, let's take this side as negative. So it means this is negative, this is positive, this is negative, positive, 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 and positive. Now in perfectly elastic collision, I would never check when it sticks, because when something sticks, it's not elastic collision at all. You used, in what question are you referring to? This yeah, you can always do that, because f, okay, so let me do it and then I'll go back. Okay, so this is basically not the answer at all, so we'll check the other ones. So initial velocity was u, and this was minus u. Okay, the final velocity was plus minus, this is for a only. Okay, u by 3, and this was plus 5 u by 3. Okay, so on this side it will be 1 minus 1 divided by 3. Oh no, wait, 1 divided by 3, that is 2 by 3, and on that side it's going to be minus 1 plus 5 divided by 3, so it's 2 by 3 u and u as well. So this is our potential answer to this question. Let's check the other ones, because you should always check all the answers in this, because sometimes it basically has multiple correct answers and then you have to check with momentum. Okay, so for B I would use let me erase this. Okay, let's erase this and let's put stuff here. Okay, for B it will be minus 0.006 and this will be plus 2u by 3. Let's calculate. 1 minus 1 divided by 6 is 5 by 6, and here minus 1 plus 2 by 3 is minus 1 by 3, so that's not our answer. And now let's check C. And yep, so for C it is plus u plus 6 and this is plus 2u by 3, so this will be 1 divided by 1 by 6, sorry, 1 plus 1 by 6 is 7 by 6, and here it is minus 1 plus 2 by 3, that's minus 1 by 3, so that's not our answer. It means A is the only correct answer, so you have to take a bit of time here. Anyway, for your question, yeah, you can always do that, because right here you see you can take m as common, it will be v minus u upon t, and then this is acceleration, so F is equal to ma. So if you find acceleration separately, you can also do that, that's fine. Now, going to this one. The spherical object falls through water at constant speed. Pretty good. And then, what do we do though? And then, which diagram showing these three forces is correct? First of all, I would like to tell you that in water, upthrust is much more. However, if you see they do not, like, you add them, put it equal to this, they're not equal. However, in 11, this seems the correct answer because you add them, it becomes equal to this. This is not correct because if you add them, it's not equal to this, and same goes for this, so no. So B has to be the right answer. Two forces act as a couple. Which statement about the two forces must not be correct? Right, must not be correct. So they act along the same straight line. Must not be correct. Yeah, that's not correct. They should be opposite, they should be same type, and they should have the same magnitude. That's correct. Okay, so the sign outside a shop is suspended from rusty horizontal hinge. At its top, the sign hangs in equilibrium, and the sign has a side of length 52 centimeter and uniform thickness, has a mass of 36. What is the moment of weight of the sign about the hinge? So basically it's saying that this sign has this side as 52 centimeters and the weight must act through the center, which is W, and they want us to find the component, right? So first of all, I would like to tell you that this is 25 because it is a corresponding angle. Then you make the components of it. So this is a perpendicular component, this is the parallel component, this is what we need. So this will be W sine 25, and then this distance would be basically half of 52. So divide by 2, so that's 26, right? Now we have moment will be equal to 36 is the mass, the acceleration due to gravity is this, and sine of 25, so that would be the weight multiplied by 26. But because it is in meters, so we got to change that too, right? So that would be 0.26 actually. So let's try do this. 36 times 9.81 times sine of 25 times 0.26, it is coming as 38.8. let's see, yeah, that's 39 then, right? All right, pretty good. Now, what is the weight of the rod? What rod? Right, so it should be in the center really. From the pivot, the distance of the rod must be equal to that's 100 minus 40 is 60, right? And here this is 60 Newton, so it would create tension of 60 newtons as well. And then we can actually make two components, one perpendicular, one parallel. So this is not required, but this is 60 sine of 30. And now we got to find the moment. So about this point, this will try to turn it this way. Okay, this will try to turn it this way, this will try to turn it this way. This is clockwise, that's anti-clockwise. So 60 sine 30 times, this will be actually 200 minus 40 is 160 equals W times 60. So let's try do this. 60 sine 30 times 160, and you got divided by 60, so this has to be 80 newtons. So this should be the answer that we are looking for. Okay then, wait a second please. Just let me have some water. All right, now going to the next question. So the next question is all about this diagram. Okay, so there are two blocks, and what about them then? Okay, so I think it should start to rain in Lahore, but never mind. Who cares? Now the block X has side X. Block has side A. Block X is placed in liquid density rho with a shaded face. Level with the liquid surface, it experiences an upthrust U. Okay. The block Y has horizontal sides A and 2A and half height. The block Y is placed in liquid 2 rho and it is shaded. What is okay, fine. So upthrust in this would be equal to rho G change in volume. Change in volume would be the volume of this A, so A cube, right? Here we have upthrust will be equal to, let's call this U, let's call this upthrust on Y. So upthrust on Y will be 2 rho times G times, now the volume will be 2A times half A times A. So this cancels out, this will be A cube again. Pretty good. So this will be 2 times rho G A cube. Now rho G A cube is equal to U, so which means Uy will be equal to 2U, which is actually C then. All right. Now going to question number 16. So you have initial volume of 2, atmospheric pressure is this. What is the work done by the gas on the atmospheric pressure when it is heated and expands to this? So the formula for work done is pressure times change in volume. Now the pressure is 101 times 10 raised to power 3 because it's kilopascals, and the change in volume is basically 6 minus 2, that's 4, but the thing is it is in centimeter cube and we want it in joules. So what you do, you could change it. So 4 centimeter cube is basically 10 raised to power minus 6 meter cube. Now how do I know this? Because if 1 centimeter, like 1 centimeter is 10 raised to power minus 2 meter, then if you cube on both sides, this will be 1 centimeter cube equals to 10 raised to minus 6 meter cube. So you can remove centimeter cube with this. Anyways, so that would be 4 times 10 raised to minus 6. Now let's try and to do this. This will be 3. It will be 4 times 10 raised to power minus 6. So that comes out to be 0.404, which is 404 millijoules, because this can be written as 404 times 10 raised to minus 3. Has to be this answer. All right, now going to the next one. A mechanical device does useful work at rate x and waste energy at rate y. Which expression gives the efficiency? Right, so basically the input should be equal to output plus wasted. Okay, so input should be equal to x plus y, whereas output is x and wasted is y. So efficiency would be x over x plus y. Do we have an answer like that? Yes, we do. That has to be C. Okay, then a car P has a kinetic energy of 240 and car Q has half the mass, twice the speed of car. Okay, what is the kinetic energy? So kinetic energy of Q is half times half the mass and twice the velocity. Okay, so this would be equivalent to, if I were you, I would actually keep half and then just write it like this. This will be 4v squared. Then I'll write it like this: half times 4 times half mv square, because I just want to see this expression. I want to put it like completely separated. This will be 2 times half mv square. So half mv square is 240 kilojoules. So 2 times 240 kilojoules would be 480. So that has to be C then. All right, if you have any questions in this, please do let me know. Okay, now a water pump is driven by engine. The pump raises a volume of this in this. So we have a volume of 0.50. We have time as 60 seconds. We have from a depth height of 30, and the pump has an efficiency of 70%. Right. And density is also given. Okay, now it seems pretty easy because you want to find useful power. Now, first of all, to find useful power by raising, we have to use mgh upon time, right? The issue is that we don't have mass, but mass can be found out by mass, and density is equal to mass over volume. So mass is density times volume. So let's replace it: density times volume times g times h over t. Now that's super easy because you just need to plug in all the values that you have. So the volume is 0.50, g is 9.81, this is 30, and divided by 60. So let's try and do it. 1000 times 0.5 times 9.81 times 30 divided by 60. So that is 2452, which I believe is 2.5 kilonewtons then. Okay. Oh, no, wait, there is an efficiency as well. No, that's wrong. Okay, wait, so what is our answer? Our answer was 2.5 times 10 raised to power 3, so 2.5 kilowatt, right? So this is our answer, but it says what is the useful output. Okay, output, interesting. If the efficiency is this, which means efficiency would be equal to output over input, which basically means that right, has to be something like, I don't know what we have actually calculated here. Let me see. What is the useful output power from the engine? The water pump driven by the engine, and pump is doing this, raises this and this. So it must be like engine should be giving more. So basically he's saying output power from engine should be the input to the pump. Clever, right? So that means that the input to the pump or output from the engine should be equal to 2.5 kilowatt divided by 0.70, because it is the efficiency, right? So 2.5 divided by 0.7 is actually 3.5 kilowatts, so has to be B then. Is it clear? Let me know if you have a question here.
No, sir, what's happening here?
Okay, so basically, let me just erase this all and then I'll explain it again. So we have this whole thing, right? Now this is like pretty okay, right? Now So what I did was, you see there is an engine, right, that is driving a pump, right? So engine gives some input, and the output that it gives is the raising of water. Do you understand what I'm saying? Right?
Yeah.
So the input to the pump has to be the output of the engine, right? It's the input to pump, right? Is it clear? So first of all, we look
Yeah.
at this whole thing. So the output of pump has to be equal to mgh upon time. So mass we found out by density is equal to mass over volume. So density times volume times g times h over t. So I basically put all the values that I gathered in my data table, and then I found out that it is about 2.5 kilowatt. Do you understand? Now
Yes.
consider this. So output of the engine is equivalent to the input of the pump. So the efficiency is equal to output of pump over input from engine, or you can write output of engine, right? Now what you do, this is 70%, so we can write it as 0.70. This is 2.5, and that's what we need to find, right? So this is going to be 2.5 divided by 0.70, so there has to be 3.5 kilowatt. So that's the clever thing about this question. This is a very tough one. This is not easy because it's all about wording, you know. Do you understand this?
Yeah. So 2.5 is not the input.
No. 2.5 is the output from the pump, and we need to find the output from the engine. You know how clever they are?
Yeah.
So I hate you. CIE. Sometimes they do this, and we have to just be clever about it. Anyway, now let's go. So this is, which spring combination has overall spring constant of this? I think we can find this, right? So extension in series is always added up. So the total extension here is 0.2 times 2. So that's 0.4. And then we use f equals to kx. So 1.6 divided by 0.4 is 4. So this is not our answer, clearly. And then we can move to this one. In basically parallel system, the extension remains the same. So we just need to do like 1.2 divided by 0.075. That is 16, which is not the answer. We need to find 8, okay? Now let's do this one. So here the extension is 0.075, and here the extension is 0. Because these two are in series to each other, so we got to add them. 0.15 plus 0.075. This will be 0.225, and then 1.8 divided by 0.225 should give us 8. So it has to be C. Okay. So you should remember. All right. Now let's see the next one. Okay. So which graph correctly labeled? Oh, this is the graph we did earlier. Remember, Anusha, you corrected me here.
Yeah.
Okay. Okay, so this I remember. See, I remember. The metal wire is stretched to breaking point, force extension. Which graph correctly labeled elastic and plastic region? The area represented in work done. So work done has to be the full one, not the half one. Okay, so this means that the correct answer to this one would be actually B or D. These are not right. Work done, D. Why? Because in this one, why this is wrong? Because elastic region should be here and plastic region should be here. All right, now longitudinal waves travel along the wave. The spring shows one. What is the wavelength? From a compression to compression has to be the wavelength has to be b. This is pretty simple. I mean, why would they even give this? Which statement about the wave is correct? Both longitudinal transfers can travel through vacuum. No way. Both longitudinal transfers waves transfer matter. No way. Matter is never transferred. Okay, it's always the energy. Longitudinal progressive waves have waves consist of alternate. No way. You got to have stationary waves then, not progressive. The particle transfers wave perpendicular direction of energy. What is this question? Oh my god. Now, the stationary sound wave, this is my favorite question. The stationary sound wave is formed in pipe that is closed at one and open at the other. The moment I read this, I should remember they want us to find the frequency. So frequency is equal to V times N over 4L, where N is always in this system, right? One end open, one end closed is odd numbers. Okay. Now, it says one of these antinodes at an open end of pipe. So wave has two antinodes. Okay. The wavelength of pipe is this. The speed of sound is this. What is the frequency of the sound wave? Is he kidding me? Okay, so length is given, right? We can find this. So the speed is 340. Because there are two antinodes. Two antinodes basically mean that it's like this. Okay, it means this is the second harmonic or the first harmonic, and not the fundamental one. So it has to be 3 here, and then divided by 4 times 0.600. So this will be 340 times 3 divided by 4 divided by 0.6. So it has to be 425, and that's A. Alright, some of you might not know this formula, right? So you might not have studied it at school or whatever. So then what you do, you should always remember, if you make this, then you know that this whole distance is 0.60. This means that there is a node here, there is a node here, and there is an antinode here. So basically this is half lambda and this is a quarter lambda. So total will be half lambda plus quarter lambda will be equal to 0.60. So you can find lambda, and then you have the speed, so you can find the frequencies, but that's a longer process, right? Okay, so if you have any questions, please do let me know. Now somebody is saying find this. Okay, so extension in this one, so in these springs the extension is this, in these springs the extension is this, but these two systems are series to each other, so the total extension would be 0.075 plus 0.075 in this one. Okay, so should remember that. All right, now going to, okay, so I have made a mess, so I'm gonna take it off. Okay, train travels at constant speed along a horizontal track. The train horns emit sound frequency this. Okay, so this is Fs. The person standing in the side of track hears the sound this. This is F0. The speed of sound is this, so this is V. The speed of train in which direction is traveling relative to the person. Now, first of all, we should understand the frequency that he is observing is less than the frequency that is actually there. It means that that's only possible if the train is moving away from the observer. Okay, and then we should use F0 equals to Fs times V, V plus Vs. So this is 450, this is 500, this is 340 divided by 340 plus Vs. We want to find Vs. Okay, so this will be 450 times 340. Oh my god, that's a big answer. 153000 plus 450 Vs equals to 500 times 340. So let's try to do it in one go. So 500 times 340 divided by 153, no, You don't have to divide, sorry. You have to minus it. 153000 and then divided by 450. So that has to be 38. So it should be away from the person, and 38 has to be C then. All right, if you have any questions, please do let me know. Now, a smooth surface has bumps on surface that's smaller than the wavelength of visible light. What is the approximate size of largest bump on the surface? Okay, wow. So visible light is basically goes from 400 to 700 nanometer. That's what visible light is. Now, if something should it's diffracting. So in diffraction, you should remember that the wavelength should be equal to that, right? So it's saying what is the maximum size of largest bump? Maximum size. So either this is this answer or this answer, but why choose between two?
It's B.
Why?
It says smaller than the wavelength.
Oh yeah, smaller than the wavelengths. That has to be B then. Very good, Anusha. So then you have to do this. What are the approximate displacement of other progressive wave at the point J and K? What other? What do you mean by other? Okay, so this is strange. So two progressive waves travel in opposite direction form a stationary wave. The graph shows a variation of distance x from the displacement of stationary wave and one of the two progressive waves at the same instant. So at J, this is, you go here, this has to be -5 and -5, right? And then at K, you have to go here, which is 5 plus 5, okay. Plus 5, no, wait a second. Why would it be plus 5? When this wave, the two waves are being -5 here at J, so this is a stationary wave, -5, and I have to draw the other wave actually here as well. This is very clever, right? Impressive. Okay. So it wants us to, what are the approximate displacement of other progressive wave at the position JK? So the other progressive wave at K, because this is a stationary wave, there has to be some other wave coming up. So basically these two, this is not right. Basically this wave should meet like here, like this. Okay, so you have to make a wave like that, like this actually. Okay, so
Sir, what?
Yeah, there has
What's
to be,
the red wave you draw? You drew?
it says that there is one progressive wave, right, that is shown on the
Yes, sir.
diagram, right, like this, you see,
Yes.
and it says there are two of them which travel in opposite directions and they form a stationary wave which is shown in the diagram as well. Do you understand? So the solid line is the
Yes, sir.
solid line is the stationary wave, right?
Right.
So we have to find the displacement of that other wave which should be at K, right?
Right, which should be opposite to the progressive wave, which is drawn.
Yeah. Which is very strange, you know. So in the opposite direction, that particular wave should be like here. If that is the case, then exactly like it should be like cancelling out the wave from this point, right? So there's no displacement here, there's a node here, which means that the other wave should have displacement right here like this, okay? And this is a very, very clever question. So here you have actually a node again, so the other wave should come here like this, and then you have basically almost an antinode here. Okay, never mind. Let's find another way. This is too long. This should not be.
Shouldn't the progressive wave which is drawn, it has a node at J, so shouldn't the progressive wave U drew also have a node at J?
Shouldn't the progressive wave, what do you mean?
I mean, you see how the progressive wave which is drawn, the J is at 0.
J is at 0. Yeah.
Right.
But that
So shouldn't
no, that J is at 0. That's fine. I agree. Okay. But the thing is, it's saying what is the other wave? Where is the other wave then? Do you understand?
Then isn't this the other wave?
No. That's just one progressive wave that they've shown. The other wave is not shown actually.
So the one you're drawing.
The one I'm drawing is the other wave. That is correct.
Yeah, so shouldn't they have the same wavelength? That's what I'm asking.
Yeah. Technically, they should have the same
Yeah, so
wavelength.
it should pass through J, no?
Yeah, it should pass J. That's correct. It should pass J. But they say what should be the displacement at this? That's what they're asking actually. Of the other wave. So if I draw, this wave right here, like this, right? So basically at J, its displacement, it has to be, it's coming as 0. But why 0? This is interesting. But the issue,
the answer in
no,
the mark scheme
I'll
is
tell you.
A.
I'll tell you. The issue is that because the stationary wave is forming here, there's an antinode here, just next to J, right? An antinode cannot be formed, An antinode cannot be formed if there is cancellation of the wave. So that's not possible. Don't you think so?
Mm-hmm.
Do you understand what I'm saying? So what I'm saying is that at J, which is like the displacement is almost -5. So this means that at this point there has to be some displacement. Are you getting my point? Which means that at this point, if this wave is 0, right? The one that is shown. So the other wave must be basically -5 in order to create J. Do you understand what I'm saying? Because the stationary wave shows that.
Alright, so at that point it must be -5.
Yes, because its displacement is here. So that's why I chose this, right? Now I really don't want to do K because it's very strange, because at K the displacement of the original wave is actually 5, right? So I want to do this. So what would be the displacement of the wave that should be there, right? If it gives you 5, it should be 5 plus 0, that should give you 5. Do you understand what I'm saying?
Wait, what could you repeat that?
Okay, let me I'll tell you what I've thought about it now. So at J, the resultant wave has a displacement -5. You agree?
Yes, sir.
Right? So at J, resultant wave has this, which means that the other wave that should be here, that should be there, must have this value. Do you understand? Because at J, this wave is 0. Like, let's call this wave 1. Wave 1 is 0. And the other wave must have a -5 displacement to create J here. Do you understand? J is this point on the stationary wave. Are you getting it?
Yes, sir.
So this means that minus 5 plus 0 gives you minus 5 right here. Okay, so these two answers was correct. Now, what did I check for k? What I did was, if you look at k, the displacement, the resultant displacement is 5. Do you
It's
understand?
5.
Is 5. Now we need to find, if the resultant comes as 5, what should be the value such that it should be there, right? It means that the other wave should have, like the resultant wave is equal to wave 1 plus wave 2 displacement, right? So wave 1 displacement right here is 5, right? So wave 2 that we're looking
Yes,
for
sir.
must have a displacement of 0 in order to give resultant of 5. Do you understand what I'm saying?
All right, I get it.
Yeah.
Yes, sir.
Okay. Which basically means that, which basically means that then this should be 0. And let's check out for L if my logic is correct, right? So if you look at L, the resultant displacement is 0. It is 0. So now we need to fill out these, right? So wave 1 at that point has a displacement of 10, right? So how can we get 0 here if the other wave had minus 10? Do you understand? So this means this has to be this one. Got it? So this is, oh my god, this is too tough, you know. Hai na? I hope you guys understand this. Everybody's clear? Please let me know if you don't still get it.
Sir, please do K again.
Okay. So K right now, the resultant at K is actually 5. Okay. And at that point, this wave 1 has also the same resultant as 5. So how can we get 5 here? The only possibility is that if the other wave had no displacement at all. You got it?
Okay, so you're looking at the smaller wave. That's the resultant?
Yeah. The stationary
Okay.
wave is the result of those two intercepting each other, right?
Yeah. Got it. Thank you.
Pretty difficult question though. So which diagram shows the diffraction of water? I don't like 1, 3s are very difficult. Now which diagram shows the diffraction of water waves in ripple tank? And has to be C. What is this question even? So they're like playing with our feelings, you know. Sometimes they're giving us very hard questions. They're like, chalo koi baat nahi. Alright. Interference fringes are produced on screen double slit interference experiment. So wavelength is this. The fringe separation is this is X. The separation of slits, that's A. What is the distance? So AX equals to lambda D. 0.60 times 10 raised to minus 3. This is 4 into 10 raised to minus 3. Lambda is 600 into 10 raised to minus 9. And then we got to find D. Okay. So 0.6 times 10 raised to power minus 3 times 4 times 10 raised to power minus 3 divided by 600 times 10 raised to power minus 9. So that has to be 4 then. Is there an answer? Yes, we do have an answer. Now here we have two bright spots. Which pair changes could result in bright spot exactly same angle as previously? Okay, first of all we need to read the first line. So this is a green light and several bright spots produced on screen other than grating shown. So use blue light and increase the distance. So first of all we need to see d sine theta equals to n lambda, right? So we want this to be constant and then we can change everything else to keep this constant, right? So let's yeah, so let's keep it here. It doesn't really matter here. So what you do, use blue light. If you use blue light which has a smaller wavelength, then definitely and increase the distance between grating and the screen. Distance between, so distance doesn't really matter because it's not even in this formula, so just take it out. Okay, it doesn't really matter. Use blue light which has smaller lambda and increase the number of lengths per unit time. So Okay, so D can be replaced by 1 upon N. And if we increase this, would it really change anything? No, it wouldn't change, right? Because then if you basically multiply here, if you decrease this and you increase the other factor, basically the change is none, which means this has to be the correct answer. Use red light and increase the distance. That's absolutely wrong, because you will then increase the wavelength and distance doesn't really matter. Use red light and increase. So if you increase two factors, then it will be twice. So that's why that's also not the correct answer. Now, not to do. A lightning strikes electrons past a point in 30 microseconds. What is the average current? So current is charge upon time. The total charge passing is 1 into 10 raised to 20, and the charge on electron is 1.6 times 10 raised to minus 19 coulomb, divided by 30 times 10 raised to minus 6. Right. 10 times 20 times 1.6 times 10 raised to power minus 19, 30 times 10 raised to power minus 6. So this is, wow, 1 2 3 4 5, 10 raised to 5 ampere. So 500 kilo ampere. So it has to be A. So much current, right? So much current. Okay, then this one. So we got EMF, power dissipated in external resistors P. Okay. The cell is replaced by a different cell that has an EMF 6 and negligible internal resistance. What is the new power that is dissipated in internal resistance? Okay. Wow. Okay. So power in should be equal to power in R plus power in say internal resistance, right? So let's small r. So this can be written as the EMF times the current. This can be written as n times time. Okay, it doesn't really matter, but let's see what I'm doing. I don't know what I'm doing. No. Wait. It should not be like this. Let me see. If both of them currently, this is R and this is R, this will get 3 volts, this will get 3 volts. Now power is V square R actually. So in this currently you're getting 3 square over R, which is basically 9 over R. This is the power initially. So that's for the first part. If you replace it, then this is like gone completely, which means this will get 6 volts now. So 6 square over R. So that's going to be 6 square is 36, right? I don't know.
Yeah.
Yes.
Okay. All right. My mental math still is okay. So 36 over R is this, and the other power was 9 over R. So how much difference is there? That would be 36 divided by 9, right? So 4 times it would increase. Do you understand? All right.
Yes, sir.
Now, a wire of uniform cross-section R, second wire is made of same material, so you have the same row, twice as long to 2L, twice the diameter, which means 2D of the first wire. What is this resistance of second wire? So we have to make the table. R equals to rho L over A and D. Okay, so the resistance of the first wire was R, rho was rho, length was length, A was A, D was D. The second wire, so this is for first, second wire has what we need to find. This is same, this is 2L, diameter is 2D, because area is proportional to d square, which means area will be 4 times then. So now what you do, right, for the first one it will be rho upon A, and the second one it will be let me write it here, rho 2L upon 4A, which is basically half of rho L upon A, because rho L upon A is R, which means R2 will be half of R. So that has to be B then, right? So you should always follow this method. It's very easy. It gives you the right insight. Now, what is the ratio of total resistance? Okay, so for this one, there is a 1 upon 2R plus 1 upon 2R equals to 1 upon R. You can do it directly. You can just half it off if you want to, but it's up to you, really up to you. So R will be equal to R in this, and then you add it to this. So in this total network, it is just 2R. In this network, it will be, this is R by 2, and this is 2R. So 2R plus R by 2 is 2.5, right? 2.5 R. Now, what do we need to do? First over 2.5 R. So that is 2 divided by 2.5, 0.8, which is 4 by 5. 4 by 5 is A, right? Is it clear, everybody? Please let me know if you don't understand this. Okay, then wait a second. Now, then going to this one, it shows me its circuit shown contains 3 cells of electromotive force in series and resistor, blah blah blah. What is the current? So basically you go in the direction of the current shown like this. You see that these two batteries are connected correctly, but this battery is connected opposite. So you do sum of EMF equals to sum of potential difference. So you do 3 plus 2 and minus 4 equals I times 5. So this is going to be 1, this is going to be I divided by 5. So I will be 1 upon 5. 1 upon 5 is 0.20, right? So it has to be A then. Oh, so tiring. Now, when the alpha particles fire at thin metal foil, most of the alpha particles pass through slit, but few are deflected at large angle. What change would increase the proportion of alpha particles deflected by large angles? Well, using alpha particles with greater kinetic energy doesn't change the fact. It doesn't really change how the atom looks, right? So we can't really change how the atom looks. We can't change the kinetic energy, whatever. Use double the thickness. Well, this could have an effect. I'll keep that in consideration. Using foil made of metal with fewer protons than nuclei, that doesn't change the fact. The reason is that still the diameter of a nucleus would be this much. It would not change that fact. Using a source emitting more alpha particles per unit time, the proportion would still stay the same. So no. So I think using double foil might, just have.
So how would that happen?
Because then there will be like multiple layers of atoms, right? So if there's a alpha particle going here, but then it goes like the other layer can deflect it backwards or at large angles, whatever. Do you understand?
Right. Okay.
And primarily I chose this because all the others are absolutely wrong, so I chose this. So you could also do this thing. Now a nucleus of Neptunium, okay, it's 236, 93 protons and 1. We know this. The nucleus decays with alpha emission and then emits a beta emission. So we can write N 236, 93, which goes to some particle Y, and then it emits alpha particle. If it does that, then y should be equal to 232 and 91. So it should go from 92 to 91 first. Is there anything that shows me that? Sorry, 93 to 91. So 93 to 91. Okay. This seems correct. This seems correct. This seems correct. This is wrong. So we are not looking at C then. And then Y would further decay, giving Z and the particle with beta particle. So this means this should be 232, and it should have an increased number of protons. What shows me an increased number of protons? This shows me, and this shows me, so that's wrong. Now now we need to look at the neutrons. So the neutrons in here should, when beta decay is happening, a neutron changes a proton, so a neutron should go less. So this shows a less neutron, so it has to be D then. Okay, not like that. You can also work it out with neutrons directly, that's up to you. Now, which combination of quarks could not be the quarks composition of hadron shown? Which could not be? Okay, we could do this. So sigma has a charge minus E, right? So D is minus 1 by 3, minus 1 by 3, minus 1 by 3. So that's minus 1E. Fine. Positive is plus 2 by 3, up minus 1 by 3, minus 1 by 3. E shouldn't it be 0?
Yes, sir.
So that has to be the correct answer, right? Because it has to be plus, and it's not correct. Woo! So finished. I think we did it on time. That's pretty good.
So, कौन सा paper?
Okay, so we have done 2021s, right? Have we done 2022?
I don't think so.
No, we haven't.
We haven't, right?
We did,
We
yeah.
haven't done specimens. We haven't done. Oh no, we skipped it because of this, right? So how about tomorrow we do March 2022 paper 22. No, sorry, 22 तो हो गया है.
Paper 2.
2 sorry. So we can do this.
Could you upload this, please? Like on Google Classroom.
So you guys do not have this, right? Right.
Yeah, that's right.
Okay, I think I can. I have
Okay.
this paper. I have this paper. Somebody gave it to me. So I'll
Okay.
it. बल्कि अब yeah. Okay, wait. Downloads. All right. So that would be the end of the class then, and I will
All right,
see you. Yes, tomorrow. Yes, tomorrow.
All right, bye.
So we will do it tomorrow. Bye. See you. Allah Hafiz.